Hello, Westmont Algebra 2 students. This is Mr. Earth here, and I thought I would walk you through the first few steps of the homework number 10 assignment that we had talked about in class today. But it's important I make a video about the first few steps, because one thing I learned from homework number 9 is that sometimes you can get completely lost if you do the beginning part wrong, and then everything after that kind of messes up. So I just want to make sure your first few steps are actually correct. So remember what we try to want to make. Our goal is to get some sort of cubic, but this time, instead of having 3 real roots, we're going to actually have some complex roots this time. So the first step is, let's create that complex root. So I'm going to come down here to the input field, and I'll just call the first root R1, and I'm going to use a capital letter because I actually want it to be displayed as a point. So I'm typing capital R1, and I'm just going to make something up. Now, I'm going to make it be at, I don't know, 2 plus 3i. So I'm typing it like that, 2 plus 3i. Now, I know what you're probably thinking. You're like, Mr. Earth, in class, you told us never use numbers. You should always use variables, and you're just making up this 2 plus 3i number. Well, that's true, but that's just to get that first dot to appear. But the 2 and 3 you're going to see in a second isn't really relevant, because I can move it around to anywhere. So just for this very first thing, I'm going to actually be typing in numbers. And notice it shows up over here, complex number. And there's R1. And even though, and it's showing up at 2 plus 3i, right? 2 across 3 up. So there it is. But my claim is just sort of this ephemeral 2 and 3, because if I'm in grabby mode right now. If I grab this R1 and move it somewhere else, like for example, now I'm at 3 plus 2i, or I can move it to 5 plus 1i, or trying to, it's a little bit hard. But I can drag it around. You can see that these numbers are changing. So, and incidentally, I actually want it back at the 2 plus 3i, so I'm going to hit Control-Z on my keyboard. So it's going to undo all the motions I did and put it back. But I just want to point out, I had to type something to get that point to appear, but really there was nothing special about the 2 and the 3. I can drag that around, so it's not really just a 2 and a 3. It represents any possible root. All right, so in fact, just to get a sort of a handle on that, remember that the standard form in general for a complex number is a plus bi. And in this case, the a is the real part of the number, the 2, and the b is the imaginary part of the number, which is 3. Notice it's just the number in front of the I, not the I itself. We don't say the imaginary part is 3i, it's just 3. Well, Geogebra can know this because there's commands for real and imaginary parts. So I'm going to come down again here, back down to input, and the next thing we should type is, because we're going to have to separate out that 2 and the 3, because that's going to be useful for writing the formulas. So we're going to type lowercase a, and it's important that it's lowercase. The uppercase a is going to end up representing the coefficients of our cubic. So we're going to do lowercase a is equal to, now it's really important, do not type the number 2 here. If you type the number 2, that means the little a is always going to be 2. But I want it to change, right? So what I actually am going to type down here is lowercase a equals real parentheses big R1. Close the parentheses. So that's what I'm typing down there. And when I push enter, boom, it shows up. It looks like I typed a equal 2. So I want to emphasize this is what people were doing wrong on homework number 9. Do not actually type a equal 2. Now if you want to see what I typed, you can, or what you typed for that matter, you can double click it, and it tells you this is what I put. I put the real part of R1. So that's okay. Well, now let's do the same thing for b. So my b is going to be lowercase b is equal to, but this time I'm going to say imaginary parentheses big R1. Hit enter. So right now, it's going to look like it's going to show up as b equal 3, because that's the imaginary. I'll go ahead and hit enter. And it shows up as b equal 3. But I didn't actually type b equal 3. People were looking at the video I made last time and saying, oh, I just type in a equal 2 and b equal 3. Don't do that. Because if you do that by typing in numbers, when you drag this point around, watch what happens when I drag this point around. See, the a and the b are changing. Okay? If you actually typed in numbers, they wouldn't change. I'm going to put it back because I like the nice whole numbers. All right, so that R1, that spot, is supposed to represent the one of the roots of our cubic. Well, if you remember what we talked about in class about the fundamental theorem of algebra, if you have a polynomial with real coefficients and a complex number is one of the roots, then you automatically know what another root has to be. It must be the conjugate of the one that you knew about. So if R1's a root, then R2 must be the conjugate. So you have a couple of different ways you can do it. So we can say, I'm going back down to my input screen now, so this should be our next step, is to say big R2 is equal to, because I want to display this other root on the screen, so I have a couple options. I could say a, lowercase a, minus bi. Oops, sorry, I forgot to put a space there. A couple of people are making the mistake. If you want to do multiplication, that's a space. So a minus b space I. If I start putting them together, it's not going to do b times I. It's going to think that's the start of some command. That's what I was doing there. So I can do that, and just to show you, if I hit it, boom, an R2 appears over there. But there's another way to have done it too. So I'm going to delete that R2 and do it the other way, because I think the other way is kind of cooler. So the way I'm going to delete it is I'm going to right-click on R2, or for you on the Chromebook, you have to hit it with 2 fingers at once. Hit delete, boom, it goes away. And let me show you the other way to have done R2, which is what I'm going to do. So I'm going to do big R2 is equal to, and I'm just going to show off that Geogebra knows the conjugate command. You can just type conjugate, parentheses, big R1. And boom. There it makes it. And again, notice it shows up here, 2 minus 3i, but I didn't actually type in a 2 and a 3. If you typed in at this stage for R2 and a 2 and a 3, when you move R1, it won't move R2. But notice, since R2 is actually the conjugate of R1, if I grab R1 and move it around, hey, look at that, the R2's moving around also. I could even dip into another quadrant, and R2 knows to move around. They're always going to be doing his mirror image, because remember, conjugate is like mirroring over the real number line. Just want to point out, though, you can't move R2. R1 was a free point. We just decided, hey, let's put that down anywhere we want. We can move it around anywhere we want. There's no restrictions on R1. But R2 was specifically built to be the conjugate. So if I try to move R2, I can't do it. R2 is always forced. I'm trying to move R2. It's stuck, because it's stuck to always be the conjugate of R1. R1 I get to move. R2 I don't. I believe that. I don't know for sure, because I'm new to Geogebra, but I think that's why the R1 is showing up in blue, and the rest aren't. So I think blue means it's like a parent to something else, and R2 means it's dependent on something. In this case, the R2 is the child of R1. So R1 can control R2, but R2 can't control R1. So all right, well, let me undo all those motions and put it back the way it was. So what's our next step? So at this stage, it's the same as what we did in class, because in class we demonstrated parabolas. And parabolas just have 2 roots, but a cubic has 3. So at this stage, you might be saying, all right, Mr. Earth, why don't we just put an R3 up here in the complex plane as well, just like we did for the R1. And it turns out that's not going to work, because we want a cubic, which means a cubic has 3 roots. Well, we've already got this complex number here that we just created, the R1. We automatically, because of FTA, have the conjugate R2, but I can't make an R3 be a complex number because of the other part of FTA. Because don't forget, the other part of the fundamental thermal algebra says that if you have a polynomial equation of degree 3, a cubic has degree 3, that means it must have 3 roots. Well, if it has a R3 up here, then it would automatically also have an R4 down here, because they would have to have the conjugate, and that would be 4 roots. So where does R3 have to be? And we had some class discussion about this, but it turns out the R3 must be on the real number line. You could not have a complex number, because then you would also have its conjugate. You might say, well, wouldn't you have the conjugate of the real number? Like if I put it at 6? Well, the conjugate of 6 is still just 6, so you would still just have 3. So all right, well, how do we put down an R3 on the real number line? Well, we do it just like the previous homework. So remember, on the previous homework, we just made up some number. So R3, so this is going to be a lowercase R3, because it's going to represent a value, not a point. Let's go ahead and put it at 6. Why not? So R3 equals 6. And again, you're thinking, Mr. Earth, you're violating the condition because you're typing in a number. But you're going to see in a minute, we can change that to be whatever we want. Well, let's get a point to show up. So the point will be capital R3. This is the next thing you should be typing down the input line. Capital R3 is going to be equal to, and again, don't type 6, 0. That was a big mistake people were making on the previous homework. Don't do that. Do not be typing in numbers at this stage. What you would be typing in is R3, 0. Close the parentheses. And now, when I hit enter, this R3 point is going to show up right here. But just to show you that it didn't really matter for it to be the 6, I can drag this point, and I can move it anywhere along the x-axis. I can't move it off the x-axis because I specifically typed in the number 0 here. So typing in that specific number forces the y-coordinate to be 0, which forces it to be a real number. So it's on the x-axis. That's what I want. But notice I am able to adjust this R3. So even though I typed in R3 to be 6, it really is just a parameter I can move around, just like I can move around the R1. So now I've got my 3 roots, R1, R2, and R3. Our next step is to actually make the cubic. So remember what the cubic formula is going to be. The equation for a cubic is going to be capital A, not a lowercase a, because we use the lowercase a right there. So can't use lowercase a and b, so I'm going to switch to uppercase for my variables. And if I put the x right next to it, it's going to think it's some sort of command, so we need to use spaces. So it's capital A, space, x, and then to do the cubed, the cube is the little caret symbol right here, 3. So ax cubed with a space between the a and the x. And then I'm going to put some spaces just for readability with the plus. Then capital B, don't use a lowercase b, because lowercase b is our a plus bi for our root right there. So it's capital B for the coefficient, then a space, x squared. And again, I did the little caret symbol there. That's shift 6 on my keyboard. Plus big C space x plus big D. So remember, there's an A, a B, and a C and a D for coefficients. Now, one thing, a mistake that students are making is they're typing this in, they were hitting enter. This is going to give us an error right now. It's going to ask us to create sliders. I'm going to do it. This is actually wrong, but I'm going to hit enter so I can show you what this error looks like. It's like, hey, do you want to create sliders? If it's doing that, you've made a mistake somewhere. At least for purposes of this assignment, you've made a mistake. So I'm going to hit cancel. I don't want to create sliders. And it says invalid input. It's like, why is it giving me an error for invalid input? Well, if you look at what we typed, we have a capital A, capital B, capital C, capital D, but we never defined those. We need to actually come up with formulas for A, B, C, and D. So I'm going to click OK here. And I'm going to get rid of this, because this is premature. I can't type this in yet and get my cubic graph, because I haven't told it what the capital A, capital B, capital C are. So I'm going to get rid of that. What you need to do is, separately, before you jump onto GeoGebra, on a piece of paper, you need to do the kind of math that we did in class. We have to FOIL out the factors. Remember, the factors are the opposites of the roots. You put those down there, you multiply them out with FOIL, you do the whole boys and girls middle school dancing thing, and don't forget the A, let me put it back so we can take a look at it. The capital A is whatever formula ends up in front of the x cubed. Now when I say formula, I mean it's going to be something with an R3, an A, and a B. So they could be mixed together in some kind of crazy way. I don't want to give it away, but you're going to get something in front of an A, you're going to get, something in front of the x cubed. Whatever's in front of the x cubed, that's going to be your A. Then you look at, after you've done the math and FOILed it all out, you look what's in front of the x squared. After you've combined your like terms, whatever's in front of the x squared, it'll be something with a little a, a little b, and an R3. That's going to be your capital B. You do the same thing for capital C, the same thing for capital D. So the capital C will be, after you've combined your like terms, what's in front of the x. And again, it'll have these variables, A, B, and R3 in it. If you're using numbers, you're doing it wrong. Don't actually put in 3s and 2s and 8s. So you keep it as A's, B's, and R3s, multiply it all out like we did in class. Whatever's in front of the x, after you combine the like terms, that's your C. And lastly, you're going to get this formula for D. D will be whatever doesn't have any x's. And it'll be some mixture of A's, B's, and C's. So I'm going to make it up. This is going to be wrong, but I'm just going to go ahead and make it up. Let's just say your capital A, after you did all that stuff, what's in front of the x cubed, maybe it ended up being A plus B. So I'm just going to put that down there. Now notice it shows up as a number here, but you don't type a number. I'm going to double click it to open it up. It's a formula. And again, it's not really, I want to emphasize, this is not that formula, okay? This is not going to be right. I don't want to give away what the formula is, because that's what your homework is. But then you're going to have some formula for capital B. I don't know what the capital B is going to be. Maybe it's R3 times little b plus A. Notice for the times, I left a space. If that bothers you, you can also put the asterisk in there. It means the same thing. The asterisk on my keyboard is Shift 8. So I'm going to push enter on that, and notice it says capital B is 19. But again, I didn't actually type in a number, I typed in this formula. And notice, even though I typed asterisks, the GeoGebra said, oh, he means times, and put it in as a space. And then you're going to end up with some formula for the C, which you figured out by the algebra again. I'm just going to make it up. Maybe it's B times A minus R3 plus A cubed. Again, I'm just totally making this up. This isn't really what it is, but boom, it came out to be the number 25. But again, that's going to change. As soon as I drag things around, all those numbers will change. And then last but not least, maybe you get some formula for D. That's whatever's left over without any x's in front after you do all the foiling. So maybe D is, I don't know, we'll make it up. So maybe it's B divided by R3 times A. Yeah, we'll just leave it as that. Again, I'm just making these formulas up, and I get some crazy number there. All right, so one thing I want to point out is one way you'll know that you've typed in formulas instead of numbers is if you drag these around. So I'm in grabby mode. If I drag my R3 around, right now my R3 is 8. Notice when I drag it around, hey, these numbers are changing. Same thing, if I drag my R1 around, wow, everything is changing. That's a good thing that everything is changing. So, all right, so now, lastly, after you've got whatever your formulas are for A, B, and C, and D, and you've input them in there with the capital letters, then you can go to your input, type in the ax cubed plus bx squared plus cx plus d. Now it won't give me an error, and now it graphs as cubic. Now that looks like a straight line. We can't actually see the cubic nature of it. I'd have to change the, I'm grabbing here. Let me pull the y-axis down a little bit. It's kind of, there you go. So now you can see there's kind of the cubic-y nature of it. So, and notice that when I switch to grab mode and I start moving things around, hey, my cubic's going to move. Now, it's not correct. So, because remember, R3 is supposed to be a root. And it's not a root, right? So remember, a root would be crossing there. If you're on the x-axis, to be a root, it would be crossing there as an x-intercept. It's not doing that because I just made up these formulas. I made up wrong formulas here. One thing I also want to put out, I'm going to stretch this a little bit. You can see that there's more here. So notice it's showing up as numbers here. Ignore this f of x. Some people were going to the input and typing f parentheses x. Don't do that. You just type in the ax cubed plus bx squared plus cx plus d. Don't actually type in numbers. If you're typing in 5x cubed and a 17 and a 26 and a 0.1, you're doing it wrong. Don't do it that way. That you can see if you open this up. I'm going to double click and open it up. That's all you should see. You should see the A's, B's, C's, and D's. Same thing here. These look like numbers. Click it and open it up. It's not numbers. It's formulas. The formulas will involve the A, B, and the R3. So, all right. So that's what your homework is. You got to put this on GeoGebra, but first you're going to have to figure out what these formulas are by doing the math. It's just like what we showed in class. So remember, the factors are the opposites of the roots. You multiply them together, FOIL the first two, then do the boys and girls middle school dancing thing for the third factor, group together your like terms, do it with variables. Now technically they're actually parameters. Do it with these letter parameters, not with numbers. Then put your formulas into GeoGebra, do your graph, and it should work. All right, if you have any questions, just feel free to ask. Good luck, guys.